السلام
Hey,
عليكم ورحمة الله وبركاته. أهلا وسهلا بحضراتكم في بودكاست إلى البيانات وما بعدها. وضفنا الحلقة دي هو باشمهندس علي الفلالي. باشمهندس علي حاليا ماشين ليرنينج انجينير في شركة جي 42. هو من الناس اللي ليهم إسهامات كبيرة حاليا في ال NLP for Arabic أو Arabic NLP وال LMS for Arabic. وكان مؤخرا يعني أطلقوا أرب جين ليد بورد، وكانت برضه أحدثت يعني صخب كبير. فنورنا باشمهندس علي النهاردة. أهلا وسهلا يا باشمهندس، وشكرا على قبول الدعوة إن شورت نوتس.
ربي يخليك ربي يخليك. And شكرا for the invitation as well, أستاذ يوسف.
شكرا. إن شاء الله هنتكلم النهاردة عن ال M evaluation ال benchmarking بشكل عام، وهنتطرق برضو لل M evaluation اللغة العربية، إيه التحديات اللي فيه، وإيه البوتنشال، وايه إيه المشاريع اللي ممكن الناس تشتغل عليها. وبرضه هنتكلم شويه عن الليدر بورد اللي هم يعني قاموا ببنائها في الشركه. فخلينا نبدا كده بالاول، يعني ايه الفرق ما بين ال ام ايفالويشن بنش ماركينج؟ هل في فرق اصلا ولا لا؟ ولو في فرق يبقى ده بيعني ايه وده بيعني ايه؟ بشكل عام مش للغه العربيه يعني.
Benchmarking and LLM evaluation are basically the same thing. It's benchmarks. It's just like another word to describe the evaluation data sets. So either for trainer evaluation, at the end of the day, there are data sets, and we have two vocabularies to describe each of them. For training, we call it corpus. For evaluation, we call it benchmark. So, but basically, there are data sets at the end of the day. So it's either like an evaluation data set or a benchmark, and it's either like an LLM evaluation pipeline or a benchmarking pipeline. Evaluation is more like I prefer evaluation better. I don't know the origins of benchmarking,
مم.
but yeah, it's an interesting word as well. But to answer your question, they are basically the same thing.
طيب، ايه خطوات ان احنا نعمل ايفالويشن لل ام يعني؟ ايه اللي بيحصل عادة لو انا حابب يعني، لو انا حابب اعمل ايفالويشن داتا سيت مثلا لل ام؟ ايه الخطوات اللي احنا بنعملها عشان نوصل لده؟ وايه ايه الشروط
Yeah.
المفروض تكون موجودة فيها يعني؟
I mean, the sky is the limit. You can create something totally new, but generally, because LLM evaluation in particular, like at the past, machine learning systems in general, they were fairly easy to evaluate because you are training a machine learning model for a specific task. You only take like 20% of the training data you are training on it, and that will be based on the training pipeline you are doing. That will be your evaluation. If it's like a classification, then you can like put your data set, your test data set, your test set as classes, and then as validation and test, and voila. All right. But for LLMs, why it's hard, because it's open-ended. You are basically trying to compress a word model into that dozens of layers of that model. So what you can get as an output is like fairly large scale of like probabilities. It's not specifically something 0 or 1 or a specific set of answers. It can be any combination of the whole vocabulary you have. So, well, any combination that makes sense. So that's why LLM evaluation in particular is much, much harder than any other machine learning evaluation in general. And what people came up with as like a solution is, instead of like giving it to be open-ended, let's just like give it a question, give it like some choices, and like tell the model to give us the most probable choice. And one way to do that is, I mean, the most like generic, the most adopted metric in the domain is the log likelihood accuracy. And how it works is, for example, given a question, I have a choice A, B, C, D, all right? So I give the model the question, I give the model the first choices, and I put that, for example, my correct choice is A, all right? And I see the logic. I don't generate any tokens. I just like do one single run, and I see the logics, and I take only the tokens A, B, C, D from the vocabulary, from the last language model head of the model. All right, I see the tokens A, B, C, D, and I see which of the tokens has a higher probability. Not necessarily 50%, or it could be like 0.01%. But if A has a higher probability than B, than C, than D, then we consider it correct. That doesn't mean that the model would have generated A. No, it could have generated a totally an entire different token. Okay, probably an apple, a banana, whatever. Okay, but just from those four tokens that we considered as choices, we take what the model gave as the highest probability, and we compare to the golden choice, which is like A, B, C, D. That that is like come as a fair solution to a huge problem as open-ended evaluation, but it has its own limitations. So circling back to your question, how generally to design a benchmark for LLM evaluation. If your metric is if the metric you are planning to use is log likelihood accuracy, you can simply have uh, have a have a set of questions with set of choices, and voila, you are good to go. If it's imbalanced, then you can go the extra mile to measure the F1 score instead of accuracy itself, because your data set is not balanced enough. But go into the F1 score, that means you need to generate a token, and generation is much more expensive than measuring the logits themselves. So probably you are better just to create a balanced data set rather than create an imbalanced data set and go the extra mile in the evaluation pipeline. That being said, that's for the log likelihood. But as I mentioned, it has some limitations as well that we are trying to tackle, not just for Arabic, but in a more general sense with generative tasks in particular. I hope that answers your question.
Yes, yes, it answers. انا كان عندي يعني سؤال في الحتة دي، هل في يعني البنش مارك او الايفالويشن داتا دي حاجة يعني اوبن ومعروفة والال امز كلها بتتجرب عليها صح؟
شو؟
يعني يعني الايفالويشن داتا سيتس دي يعني حاجة اوبن والال امز بتجت تيستد عليها بحيث ان هم يعني ايه يقول لك مثلا هو جاب على الايفالويشن
مهم.
داتا سيت دي مثلا سكور معين. هل في يعني ال امز بتتدرب بقى اوريدي او ده بيخش لها في التريننج عشان تبقى عارفه ايه الاجابات الصح ولا ده مش بيحصل؟
Well, hopefully not.
امم.
Hopefully, we hope that people do not train on benchmarks,
امم.
but unfortunately, that's not the case.
امم.
And that maybe that could be the discussion once we start discussing ROGen, we can circle back on this one. But yeah, generally, you are training next token prediction for you have a huge corpus of text. You are not particularly training your model to, if I give you a question and a set of choices, you give me A, B, or C, or D. No,
امم.
that's not the way you optimize your model, because that's not how it's going to be used, right?
امم.
But some people might do it, and we have seen some evidences that unfortunately some people did it, not in English, of course, but in other low resource languages that people generally tend to pay less attention to. That's very unfortunate. And this was done mainly to hack the benchmarks. For your first question, were these benchmarks available? Most of the benchmarks empowering the leaderboards in general are publicly available. The Open LLM leaderboard by Hugging Face, it's empowered by benchmarks, are publicly available, and you can even find them in the Hugging Face datasets hub. The Open Arabic LLM leaderboard that we have created with Hugging Face, and that was sponsored by TII as well. The benchmarks we are adopting there are publicly available as well. And yeah, this is like good and bad at the same time. So good because people have a way to reproduce or have a way to test themselves before they make a model public. Okay, so they can evaluate internally before they make their model public, and they only make it public once they have the set, like they reach a certain threshold, and they know that once they will submit their model in the leaderboard, it will end up being highly ranked. All right. But also, this gives some people with malicious intent, Allah yahdihum, the ability to train on these benchmarks. And train on the benchmarks this is like the simplest way of data contamination or
Mm.
benchmark contamination. But there is more sophisticated ways to do
Mm.
it, and
Mm.
much harder ways much harder to detect ways. If you
Mm.
just like train right away on the benchmarks,
To be easily
it's not
to.
easy. It's
Mm.
not easy to detect, but at some point, once you analyze the model behavior in these benchmarks, you can say with a high confidence that this model
Mm.
was trained on the benchmark. But recently, there is, for example, data laundering, where you train one model on the benchmark and you use it as a distillator to do knowledge
Mm.
distillation into your model. That's called data laundering. So this is a much harder technique to detect. Okay,
Mm.
but unfortunately, some people, I don't know if someone did it before. Nobody was caught because so far we don't have a robust technique to do data contamination detection. All right. And here is like the thing. There is now two schools. One is, for example, with the wall with Open Arabic Academy leaderboard. Let's make the benchmarks open, and we just like trust the community. But with Aragen, we are adopting another philosophy. No, let's not trust the community, and let's make it private for a certain period of time, and then make it public for the sake of reproducibility and transparency.
مم. اوكي نايس. انا عندي سؤال تاني برضو. ده كده بشكل عام ان احنا بنيفالويت ال ام، هل في
Hello.
ايفالويشن؟ نعم. كده في كونكشن ولا كسمعني؟
Okay, now it's good. Now it's
اه
good.
اوكي تمام.
Yes.
فكنت بسأل يعني دي الايفالويشن داتا سيتس اللي احنا بنيفالويت عليها او بنبنش مارك عليها ال ام. هل في مثلا ايفالويشن ماتريكس لسيرتن تاسكس زي مثلا السمرايزيشن الترانسليشن لو احنا عايزين نتست ال ام مثلا في حتت معينة او تاسكس معينة؟
Yes. 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 There is. There is definitely like summarization or translation, for example. There is data sets that were created specifically to evaluate the model performance in these tasks. And of course, in these tasks, you don't use, for example, you don't use log likelihood accuracy. There is more fairly designed metrics for
مم.
these, for example, blue and rouge scores,
مم.
which are like an n-gram matching with a reference answer technique. So yeah, there is these, and but at the end of the day, you want, for example, to measure summarization. Okay, you want to evaluate summarization of let's say Gemma 9b or JACE 30b or whatever. Okay, if you give it like a paragraph, okay, and you give it in the prompt the instruction, give me the summary of this paragraph. The model can give you just the summary,
مم.
okay, or it can start طبعا أستطيع أن أساعدك في هذا
مم.
الموجز, or it can start with any other way. You don't really control how the model will start, and it can give you, for example, dash 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 as markdown separator, dash 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 the summary, then dash dash dash, then I hope this was helpful. I hope this was helpful in Arabic is what.
أتمنى يكون ده.
أتمنى أن يكون هذا
بس.
مساعدا or whatever. Okay. So yeah, it's you don't really control. But for example, for a model that was trained to do summarization, was trained on the task as summarization, or to do classification, or to do translation, all right, this you don't have an open-ended generation.
مم.
You know that the output you get is the thing you are measuring, no more, no less. So that's why it was a discussion uh, to include summarization translation in Open Arabic LLM Leaderboard v2 that was recently released, but that was the main challenge. And we saw that the only way to actually do it is by revoking an ill-limited judge, the same way we did with the al-raj,
مم.
the rag task that we added. But this by itself has its own challenges and limitations, and it's fairly more costly. So at the end of the day, we decided like it's not really worth it. And if generally a model is good in these tasks, it gives you a high signal that it could be good in summarization or translation. Not necessarily, but it could be.
مم. اوكي. طيب تمام، خلينا نخش برضو على الجانب بقى العربي في الموضوع. ايه الفرق ما بين يعني البنش ماركينج او الايفالويشن لل ام بشكل عام والعربي؟ يعني ايه الخصوصيه اللي موجوده للغه العربيه؟ وبعد كده ممكن نشوف ايه الحاجات المتاحه بقى في اللغه العربيه يعني.
في ال يعني في log likelihood accuracy there is not much differences. Okay,
مم.
it's I mean besides if the language it's the question itself was really was highly like culturally related to a
مم.
specific region. For example, Sa'id في Misr, or like something that's only Sa'ida will understand. Okay, so this can make a difference. But on a general basis, in log likelihood accuracy, because the way the the NLL, normalized look likelihood accuracy, is working is by detecting like just the 4 tokens, the 3 tokens, the 2 tokens you are targeting, and measure the highest probability among them, among these set of 3, 4, or 5 tokens. Okay, no more, no less. So this is more like restrictive way for the model.
مم.
But in generative tasks, for example, 1 token can change the whole answer. So, and for Arabic, because mainly these models, let's say, besides JACE, ACE, GPT, and Silma, I'm not aware of any models that are open and they were like targeting Arabic as a first language. So let's say, for example, Gemma or Llama 3.3, okay? They support Arabic. They are not saying it,
مم.
unfortunately. They are not saying it, but they support Arabic. Okay, but mainly they are like an English first
مم.
models. So because they just like had Arabic as part of their training data. For example, I don't know, Sat. Sat is friend in Moroccan Darija. Probably, I don't know. Maybe it occurred in the training data, but this is like just a toy example that probably Sat was never part of the training data of that model. So, for example, if you put Sat instead of Sahbi, which is another Moroccan Darija way to say Sadiq, okay, that could change the way the model will answer the same question. So that's the main challenge for Arabic, and not just Arabic, to be honest. That was also like observations that were made in Hindi models, in Kazakh models, Japanese as well. So like generally the languages that are in a more general sense low resource, they tend to have these challenges between what is represented on the internet, on the common
مم.
crawl, okay, and what people actually use on a daily basis. And that makes the model behavior like very badly.
مم.
Okay, so the generative tasks are the more challenging one in that regard, and I think it's more for an opportunity rather than a challenge, because this way you can really unveil like the truth behind these models, like the true performance of these models in a culturally aware environment, if we might say.
طيب هل يعني هل الايفالويشن الموجوده دلوقتي بتقدر تكاتش الحتت دي، ولا هي بس برضو مجرد اسئله وتشويسز؟
Well, so far that's what we're trying to do with Aragen. Definitely, it's not perfect. It's not complete. We will in March, inshallah, we will release publicly the evaluation test set that we were using, and we are counting on people to go through it one by one and criticize it, and tells us what should be done in the third version of Origin. Uh, so yeah, but that's the overall idea behind Origin, is to capture these. For now, there are no dialects. There are no Sat, Sahbi,
مم. مم.
Shiri. No dialects of in Origin. They are purely Arabic, but we wanted it to make it as much as possible a culturally aware questions that are inherently related to the region and the Arabic culture and history in general. We have a section of Arabic history in a more broad sense, and the Islamic era as well. So that's what we try to do, and this is like the very hard challenge when we discussed like how to create these evaluation test sets. For an MCQ, it's easy.
مم.
Just create like a question, your question, and just put choices. Okay, but for generative tasks, it's hard because one token in that question can change the model behavior
مم.
completely. All right, so yeah, that's why it's an opportunity to unmask the truth behind these models, but also it's a challenge because you may rephrase a question in a certain way, and some other people will come like, no, I don't accept this way you are phrasing this question, or I don't accept this question in general. Okay, so for if you want to go for from a benchmark design perspective, if you want to go for an MCQ, it's not like easy, but it is fairly easy compared to generative tasks. And yeah, I think we are lucky. We have a really good community of Arabic NLP, and we believe. I mean, working together, we believe we can like iteratively progress on those benchmark designs, because again, the benchmark design is the hardest part in evaluation in general, not the metric itself, but how to create those benchmarks.
مم. الاوبن Arabic LLM ليدر بورد هي مبنية على MCQs ولا؟
Yeah, MCQs.
طيب هل يعني انا عندي برضو سؤال، هي ازاي بتتبنى؟ هل مثلا بتاخدوا الحاجات المقابلة في اللغة الإنجليزية ويتم ترجمتها، ولا يعني ازاي بتبنوا الداتا سيت دي نفسها؟
Nice, interesting.
مم.
Well, that was part of the first version of Open Arabic LLM Leaderboard, WAL for short. We took a lot of data sets. We took everything that we could put our hands on. Okay. So and
اللي هي
like
اللي هي موجودة باللغات التانية اوريدي، صح كده ولا؟
yes, it
اوكي.
was Toxygen, it was ARC Challenge, ARC Easy. It was like a lot,
مم.
and most of them were machine translated data sets.
اوكي.
We had also Algafa, which was a suite of previous benchmarks, okay, that were like Arabic native benchmarks. We had exams because we believe exams is very special, and for me it's like the only column, even in the first version, the only column that I go to when I want to know the truth of a model. Is the model really good or not? Okay, so
مم.
for me, I was always targeting exams as a shortcut. So
مم.
exams is really good, and
yeah,
it was part.
يعني can you explain more about what is exam? Is it like let's set
Yeah,
also, or it's
exams was a benchmarking suite that was created by a group of researchers for multiple languages, including Arabic. Okay, so what they did is basically crawl the internet for like exams, as the name suggests, and they put it in an MCQ format.
okay.
So I believe like the Arabic set of exams that were like a couple of exams from Morocco, from Saudi Arabia, from Oman.
Mm.
I mean, there was no mention in for these countries in particular, I think, except in the paper, if I remember correctly.
Mm.
But that was the idea, to crawl exams from the web, and these exams were actually exams of high schools
In different subjects, in different.
in different in kind of like a different subjects. I
Okay.
mean, originally,
Mm,
but Arabic has one thing particular, that there was no train or validation set. There was only test set
mm,
of Arabic. For other languages, they had train, validation, and test.
mm,
Okay, and let me tell you what could happen here. Why exams is so interesting? Because first, it is generally a representation of the core knowledge of the model. If a model is doing really good on exams, that means it is fairly a good model. That's one. Two, it's a big signal of data contamination, because
mm.
as I mentioned,
It's only tested,
exams
so.
didn't
Mm,
have train validation test.
mm,
Okay, so what people tend to do in general, uh, I don't know, Google, Mistral, Meta, or whatever, that they would simply like crawl everything, and for not just for exam but for any data sets, they will check the split automatically, and if there is no validation or train, okay, they will
mm.
include the test in training.
Okay.
They
Mm,
will use the test in
mm,
training itself, which is a crime. For me, it's a crime.
mm.
You shouldn't do that. It's called test for a reason. It was called test by the authors for a reason. So if you find a test, keep it test, for God's sake. But generally, that was mostly the case. We don't know that for sure, of course, but from an analysis of these models, you can see that they tend to do really good on exams.
Mm,
Like, they are good models, but apparently they are way like highly optimized for exams, and that's
mm,
why I love exams, because it's either that it tells you if the model is really bad, if the model is good, or if the model is too good to be true.
mm,
Okay.
mm.
So if it's too good to be true, it's contamination. If
Mm,
it's too good, then it's a really, given its model size, then that's a good model. You can build on top of it, fine tune it further, do whatever you want on it. If it's a bad model, then just stay away of it from it. So that's why I loved exams. Exams was part of Algafa, but we decided to make it a separate column by itself for visibility. So it's not concatenated within Algafa. Sorry.
yeah.
So it's not concatenated within Algafa itself. And then we had Arabic MMLU. We had ACVA, which was like part of ACE GPT release. Uh, Unfortunately, that was not really a great benchmark. It had multiple issues, both factuality, imbalance of the test set, and it wasn't mainly an MCQ. It was yes or no kind of questions,
Mm,
and if I remember correctly, 60% was no. So the random baseline was 60% anyway.
mm, mm.
So if your model achieves 60%, it doesn't really mean it's a good model. It's mean it's just like random baseline.
Oh no.
So, so yeah, uh, and there were like other parts of other data sets as well in the V2. The V1. In V2, we decided to get rid of anything that is not native Arabic.
So
And
anything that was translated was removed?
yes,
Okay.
all the tasks that were machine translated were removed. We have so far one translated dataset. It's MMLU, the classical MMLU, but
Mm.
that one was human translated,
Okay, not machine.
not machine translated.
Mm.
And for that, we managed to convince our friends at Mohammed bin Zayed University of Artificial Intelligence to share with us some benchmarks they had like locally, particularly the human translated MMLU that was done with Inception, and the Medina Q&A, and if I don't remember the third one, but if I remember correctly, there were like three data sets shared by by Mohammed bin Zayed University of Artificial Intelligence. We also included our trust from SS AI,
Mm.
from SS lab in Jeddah, I guess. and yeah, we had Arabic MMLU, which actually was a loss because Arabic MMLU, the Arabic version, not the translated version, just like
another one. Okay.
MMLU name,
Mm,
but the questions and the tasks are entirely different from MMLU itself.
mm, mm,
So the Arabic MMLU, which was also created by Dr. Fajri Koto and his team from the Mohammed bin Zayed University of Artificial Intelligence, that should have been actually included in V1, but
mm,
at that time we didn't. There were like 1 month difference between its
mm,
release and the leaderboard release, and we didn't really knew about it, to be honest. So yeah, but yeah, that data set could have been part of V1 instead. But I'm glad we made it now in V2.
mm. جريت. دي كده للحاجات اللي هي الام سي كيو. انت قلت
Yes, and all of them are
الام سي
MCQ.
كيوز.
Yeah.
طيب هل بيبقى في مثلا يعني measurements او حاجه اللي انت تتاكد ان هي بتغطي different aspects of اللغه العربيه مثلا، مواضيع مختلفه او حاجه شبه كده، ولا ازاي بتاكدوا من جوده البنش مارك نفسها قبل ما تعملوا لها ريليز؟
Yes, that's a really good question, which I don't really have an answer to.
يعني هل بيبقى في
No,
مثلا ميجرمنت ليها
it's
بشكل
just,
ما، يعني بتيفالويتوا الايفالويشنز دي بشكل ما، ولا ده ما بيحصلش؟
well, generally we just trust the authors. Okay,
مم.
so we believe the Arabic MMLU authors did a good job.
مم.
We believe the Aratrust authors did a good job. We fairly go because there are like a couple of hundreds of samples, and it's quite hard to go through each of the samples, and
مم.
even judging those samples are fairly subjective. Probably you will see it as a good sample, I might see it as a bad sample, whatever. So yeah, we go, for example, through the papers, and for example, for Arabic MMLU, they are covering in general 40 tasks, okay, from
مم.
accounting, Islamic studies,
مم.
uh, Arabic Arabic rules, okay, in the grammar, math, astronomy, whatever, okay.
مم.
For Aratrust, for example, if I remember correctly, they cover eight tasks: ethics, discrimination, and other ones that I don't remember. I have a terrible memory. Sorry. Uh, well, Medina Q&A is fairly for Arabic. It was extracted from Medina website, and it's a
مم.
website to teach Arabic and
مم.
online, and it's fairly for mainly for Arabic grammar in general. Um what else? So yeah, that's the thing that like our main metric is trust the authors. We
مم.
believe the authors did a good job. Otherwise, it's not worth
مم.
publishing in a paper. But yeah, that's the thing. The community again comes uh,
مم.
into the picture. For example, in ACVA, uh, we we like noticed some issues with it right after the release. For example, Zaid Liafi mentioned some issues, if I remember correctly, on day one of the leaderboard. But again, we received like a very detailed report of issues from Bashmuhandis Abu Bakr
مم.
Sulaiman. Okay,
مم.
so I remember he contacted me, and he was like very detailed in the issues, like, and the benchmarks in general, with a particular laser focus on ACVA. So yeah, the idea here is the community plays a huge role, that they can go through these data sets, and they provide the feedback that, but because we don't own these data sets, we can
مم.
give back to the authors. We have established like a direct communication line with the authors. So yeah, we can go back to them like, okay, here's the thing. There is an issue with this particular sample, this particular subset in this data set, and yeah, it should be fixed or removed or whatever. And that's how you like get all
مم.
v3, all v4, Argent v3, you
مم.
see. So and it's all iterative, and that's the thing. It's always iterative, and it's always building up. Once you saturate a certain benchmark, then you start looking for other benchmarks that are not saturated yet. And that's how your model capabilities evolve with time. That's how you develop the models. So
Mm.
that's the idea. We really hope the community will take the time to go through these samples
مم.
and criticize it
مم.
as much as they
مم.
can.
انا عندي سؤال طيب في الحته دي عشان نفهم شويه التشالنجز او المشاكل بتبقى موجوده. ممكن مثلا تقول لي ايه الايشوز اللي كانت موجوده في 1؟ يعني مش لازم يعني اكزامبلز منها مثلا، بحيث ان الناس تبقى فاهمه برضو ايه ايه المشاكل اللي ممكن تبقى موجوده في الايفالويشن. ذاتس ات.
I have a terrible memory, so I don't remember exactly the sample, but let me give you an example. For example, for ACVA, right? First issue was it was imbalanced. Okay. It was a yes or no questions. Okay. But we
دي
can
زوان ان انت منشن ان هي كانت 60% منها نو، صح؟
صح.
اه اوكي اوكي.
So, but we can be flexible with these. The main issue was the factuality errors, and we run like a small experiment, like on I think 1,000. I don't remember correctly how much samples we had, but I remember the percentage that 13% of it was factually incorrect. And why? How I mean, for example, factually incorrect. مثلا السؤال هو مثلا في سكشن المغرب، الرباط هي عاصمة المغرب. There is two options, yes or no. صح خطأ. Okay. والgolden answer is خطأ. That's factually incorrect. So we are penalizing models that are actually correct. You know, that they say صح الرباط هي عاصمة المغرب. We are penalizing them and we are rewarding the models that are not aware of this information. So again, that was like 13% of it factually incorrect. That was like a human annotation experiment on a fairly small sample. Maybe the sample we choose had more incorrect samples. Maybe not. Maybe if we go through the whole data set, we find a larger percentage. We don't know. But I believe that experiment gave us like a glimpse on how much is incorrect samples in that data set. So that was a huge problem. For Arabic MMLU, the one we had translated, like it was translated using GPT 3.5, I remember, if I remember correctly. And 101 problem is bad translation. So you know, I mean, you can understand the question, you can make sense out of the question, all right, and you can make sense somehow out of the choices, but that's not how a benchmark should be. That's not like a question shouldn't be like left for the reader to interpret it their way, because we both might interpret it in two different ways. So yeah, that was like, and that was because of bad
machine translation.
low quality translation. And that's applied on other tasks as well, like Toxygen or ERC challenge. They were a little bit higher quality, to be fair, but again, they were machine translated, and as long as they are just like simply machine translated, it's better to stay away from these samples. So that's why we decided that no more machine translation. best
even
best
with
case
even
scenario.
with المودلز الموجودة حاليا اللي هي ليها كواليتي كويسة.
Unless you want to do it yourself. For example, you want to translate MMLU, the whole MMLU, the 14,000 sample, with O1, for example. That could be a huge, big contribution to the community. But that could be very, very expensive as well. And to be fair, it's for MMLU, that was an example. Definitely, it's not worth it to do it for MMLU. Now we have the Arabic version of MMLU from OpenAI that was human translated. We have the human translation from Mohammed bin Zayed University of Artificial Intelligence and Inception. So those are both human translated versions of Arabic MMLU. And in the PR that we submitted to Light Eval in order to merge these tasks, we did a small ablation study to compare like the performance of Qwen 7b and Qwen 2.57b and Qwen 2.57b instruct on the different versions of MMLU, including the Arabic MMLU, including the Arabic translated, machine translated MMLU that we used in the previous task. There was another MMLU which called Okapi.
Mm.
Okapi, it was like just a paper to translate. I don't think if it was just for MMLU or other benchmarks as well, but they were translating for many languages, Arabic, Korean, other languages. So we compared the performance of the model on Okapi MMLU as well, on OpenAI MMLU, the multilingual MMLU, and on the human translated MMLU we got from the university. And what we saw is the models tend to do worse, the good models tend to do worse on the machine translated
Mm.
MMLU versions, and tend to do better on both OpenAI and MBZOI versions,
Mm.
right? And they fairly correlate with Arabic MMLU, the Arabic native adapted version of MMLU. They fairly correlate with it. But the low performance models, all
Mm.
right, they tend to do
Opposite.
better
Mm.
on the machine translated MMLU and worse on the human translated MMLU.
Mm.
So
هل ده
that's
بسبب الداتا اللي هم متدربين عليها؟ يعني هل مثلا المودلز الأسوأ متدربة على ماشين ترانسليت موديل، ماشين ترانسليت داتا، ولا ملهاش علاقة؟
mm, uh, it could be,
مم.
it could be, but not necessarily the case. It's just like the the bad MMLUs, for example, sometimes they have, for example, wrong choices
مم.
as well. So
مم.
that could be one of the reasons. But yeah, the low, the general conclusion we had is like the low quality, the benchmark, it is higher rewarding for the bad models
مم.
and lower rewarding for the good models.
مم.
That's why you need a high quality benchmark. You can just like evaluate on anything, and you will expect that the good models will still perform good. That couldn't necessarily be the case.
مم. مم. جميل. انا عندي سؤال تاني برضو في الحته بتاعت ال MCQ questions. لو انا مثلا دلوقتي عندي تاسك معينه في اللغه العربيه، وليكن مثلا خلينا ناخد مثال جزء المواريث مثلا، وعايز اشوف ونفترض ده مش متغطي في البنش ماركس الموجوده او في الايفالويشن سيتس الموجوده، وانا عايز يعني اكريت داتا سيت للتاسك دي عشان اجرب بيها المودلز المختلفه واشوف ايه افضل موديل. يعني ايه الخطوات اللي المفروض اعملها؟ هل مثلا ان انا استعين بالدومين اكسبرت، ولا هل مثلا اروح اشوف المواقع الاسلاميه مثلا بتتكلم في الجزء ده وابتدي اخد الاسئله من، يعني لو انت حابب تعمل ده هتعمل ايه؟
Uh-huh. Well, historically, that's how it was done,
مم.
using domain experts and human involvement, heavy human involvement.
مم.
But currently, we synthetically generate data for all sorts of things,
مم.
literally all sorts of things.
مم.
So why not for evaluation as well?
مم.
The subject you mentioned is what exactly? الموروث.
المواريث، يعني حساب الميراث مثلا.
Okay.
مم.
So assuming we have a book for that,
مم.
uh, just assuming we have a book for that, what we can do is simply like feeding chapter by chapter, paragraph by paragraph, or section by section, and just ask the model to generate a set of questions and a set
مم.
of answers for each
مم.
question and answer. Okay, that's it. Then once you get like these thousands of questions,
مم.
you can simply here you can the model, the human enters the picture, and you
مم.
can start doing like the human involvement instead of generating the questions
مم.
themselves. You can simply
reviewing.
uh, instead of using, for example, 10 domain experts, you use one, or you
مم.
can use it could be you as well, to simply like filter out the questions that are irrelevant, the questions that do not make sense, the questions that's controversial,
مم.
all right, and keep a set that is like a silver set.
مم.
Okay, then you can, well, now you have the correct answer, one choice. So to add the other three choices or the four choices or whatever you want, you can go two ways. You can simply uh, take away your choice and sample 4 choices from the remaining choices randomly and put them together, and voila, you have your MCQ. Or you can make it a little bit harder by feeding it to the embedding space and mapping the questions that are generally close to each other.
Mm,
All right, and you choose the choices of those questions.
mm,
Okay,
mm, mm,
so the choices are more misleading,
mm,
kind of like they are generally related, so they are a little bit harder to because that was a behavior that was noticed in the model performance, that in MCQ, that one of the main challenges of MCQ is that the model answered the question correctly doesn't mean the model knows the information. It
mm,
only knows what it's not the correct answer. That it
mm,
knows. And
mm.
that, to be honest, is similar to what we used to do in high school anyway.
Yeah, yeah.
So, so yeah, it's quite interesting.
Mm,
It's quite interesting, but that's not how we want to
mm,
evaluate these
mm,
models, all right?
mm, mm.
So, for example, the choice C is the correct one. It doesn't mean that the model knows that the choice C is the correct one, but it knows A,
A,
B,
B, D is
C
wrong, yeah.
are not correct. They
Mm,
are irrelevant.
mm,
So it gives higher probability to C rather to A, B, and D.
mm,
Okay, and it ends up winning. Good, great.
mm,
So just to make your benchmark a little bit harder, you can do this embedding mapping in order to extract the choices from questions that are similar in the embedding space. So you can like confuse the models that are not really good. Okay,
mm,
but still, this doesn't solve this issue entirely. It just like to an extent.
mm,
But to solve entirely the issue, the generative tasks is, at least for me, they are the answer
mm,
so far.
mm,
So yeah, that's how I would create a benchmark for a
mm,
task X.
mm. هل في يعني minimum amount of questions that should be أو يعني minimum amount من الأسئلة لازم تكون موجودة، ولا يعني الموضوع بيتحسب ازاي لكل تاسك مثلا؟
Great question.
Mm,
I don't think so. Some
mm,
people say yes. Personally, I don't think so. For example, the Vicuna benchmark, one of the largest used benchmarks in general. All papers use Vicuna results in
mm,
their evaluation section in the paper or models. Vicuna is 80 questions,
mm,
so
mm,
80 is not fairly large. All
mm,
right. For us, we decided to go with 300 questions max in Origin, for example,
mm,
because we have seen that this is more than enough to reflect the model performance in general.
mm,
So so yeah, but it also depends on the task at hand. If you have, for example, you are creating a generative benchmark for LLMs,
mm.
but for summarization, all right, you have thousands
Cases
of
يعني. Mm,
samples
mm,
in
mm,
summarization
mm,
eval
mm,
sets.
mm,
Okay, so you can simply convert them to a generative kind of generative like task in order to evaluate the LLMs. And summarization is a highly optimized task in general. So you want more samples in order to capture more flaws in the models. Okay,
mm,
but for example, in a task that is generally hard and generally scarce in terms of data points as well, so I think 100, 200, 300 is more than enough from a general perspective.
mm. جميل. طيب انا عايز اخش شويه برضو ناحيه الجنريتيف جنريتيف تاسكس او جنريتيف داتا سيتس. يعني خلينا ايه بدايه كده ندي يعني لو تدي مقدمه سريعه عنها، ايه الفرق بينها وبين الام اس كيوز؟ ايه الفرق، يعني ايه التشالنجز الموجوده هنا مش موجوده هنا؟ انا عارف انت
Mhm.
اتكلمت عنهم سريعا، بس يعني ايه ممكن نفصل شويه فيها
Yeah, right.
وبعدين.
Yeah, so far we had not just Arabic, I mean, generally in the evaluation space,
م-
we had two ways to do LLM evaluation.
م-
One way is following the Helm framework from Stanford, and which was like the foundation of the LM harness, and therefore the Open LLM leaderboard of Hugging Face, and now Light Eval. So this way is by studying the choices of a question. okay,
Mm.
which we discussed a lot so
Mm.
far. So yeah, again, you are just like sampling one choice out of the 4, 5, 6, n choices that you have for a certain question, and you measure the highest probability of these samples compared to the golden reference, the golden choice, which is like a specific token, A, B, C, D, E, Alif, B, Jim, Del, so one token to make it easier,
Mm.
uh, because you don't want to generate.
Mm.
And this was like one of the ways currently. The second way is what we call the preference-based benchmarks. And for the preference-based benchmarks, the most famous way, the leaderboard is the Chatbot Arena. So Chatbot Arena is a preference-based benchmarking method, okay, based relying on human crowdsourcing, okay. So the
Mm.
Chatbot Arena, how it works is you go to the Chatbot Arena website and you type your own prompt, okay, whatever you want to ask, you are free to do. There is no that's actually one of the strong suits of the Chatbot Arena is there is no benchmark. You are the benchmark,
Mm.
okay. So you write whatever you want, you get two answers. At the end of the day, you get two answers, model A, model B, with no idea what is model A or what is model B.
Mm.
Then based on you choose your preference,
Mm.
okay. So I prefer model A, I prefer model B, or I prefer both, or I don't like neither of them. Okay, and based on the choice you make, there is an ELO score that is being calculated. So ELO is similar to chess players, how chess players are ranked, or how Dota 2, I guess, they also use ELO score in ranking of the Dota 2 players as well. So, or I think tennis as well. I don't know.
Mm.
I saw tennis use ELO score as well in the ranking, but I'm not sure. So yeah, that's the general idea. You are in a competition,
Mm.
okay. I'm not gonna talk about like why this is even it's you they don't have a specific benchmark and you create your own benchmarks. That's good from one point, but it has its own limitations and challenges, and I'm not gonna talk about that for now. But usually in a general sense, this is two ways of doing benchmarking: MCQ, log likelihood, measure the highest probability among the target tokens, that's it, or preference based, using human as human crowdsourcing. Or some people go the extra mile, and instead of using humans as crowdsourcing, a human crowdsource as like the evaluator, as the preferences, they use an LLM, all right, as a
Mm.
proxy of the human. Okay, so they use an LLM, they give it two choices, A, B, and B, and choose which one of you, which answer is more preferred by you, and they again calculate the same ELO score. So the LLM here is just like a proxy of the human component.
This is like
So
LLM as
that's
a judge, right?
well, this was one of the early ways to do LLM as a judge,
Mm. Okay.
is to proxy the human judgment. Another way to do LLM as a judge is to give it like, instead of giving it model A and model B answer, you give it only one model, one answer,
And ask it
okay,
to
and you
score
ask
this.
the judge,
Mm.
to like give it a score from 1 to 10. That's a
Mm.
Likert scale, on a Likert scale from 1 to 10. And again, this is like preference.
Mm.
You are asking the judge basically to how much you prefer this answer. And what happens then is usually models in both scenarios, either you give it model A, model B, or you give it just one answer on a Likert scale for 1 to 10. In both scenarios, the judge tends to give higher scores or prefer more the answers from it or from similar
Mm.
models. For example,
Mm.
if the judge is 4.0, GPT-4o, it will tend to give higher scores to GPT-4o answers or GPT-4o mini
Mm.
rather than Claude,
Mm.
because it aligns with the way the
I
model
see
would
the way.
have
Yeah.
would
Mm.
have answered,
Generated. Yeah.
the
Mm.
data distribution of the model.
Mm.
All right. So far there was like these two ways, and the clear difference between them is in log likelihood based, you do not generate tokens. You do not go to generate. You simply do one run. You see the logits of the tokens of your vocabulary in the last layer, and based on that you make your decision. But in preference based benchmarking in general, you do generate tokens, and sometimes a lot of tokens, a whole response for a certain query. So and that is generative task.
Okay.
Is that like fairly enough for the question? Because so far I don't remember the question.
Yeah, yeah, yeah. I think it's yes. But what is like? Yeah, I know there is of course a need, but what is like? Uh, why we don't only يعني نعتمد بس على على الام اس كيو اللي مخلينا احنا محتاجين كمان ان احنا نعمل جنريتيف تاسك.
That's a good question. All right. So MCQ was fundamentally created by academia. So it came from the it dates way back, but generally the Helm framework from Stanford is the one that unified kind of like the whole thing. So yeah, the MCQ is meant to evaluate the core knowledge of the model. Okay. So if a model knows Rabat is the capital of Morocco, that's a core knowledge. If a model don't know this is core knowledge. Okay. It's not in the core knowledge of the model. Okay. But given the issues that we discussed before, if the model answers correctly a question, it doesn't necessarily mean the model knows
No.
the correct answer. That's one way. Second way is, which is more interesting, is it does not reflect that this model is really good for users. Even if it's the top, even if it answers all the benchmarks 100%, this doesn't really mean that this model is good to be used. Okay. And at the end of the day, we are developing these models to be used, not just like to prove an idea or to prove a theory. All right. And an example of that is NVIDIA Nemotron 70B. So NVIDIA Nemotron 70B, it's a really good example because it managed to rank the best at some point, I think first or second. I don't remember exactly, but it was, let's, for the sake of the discussion, let's say the best on the Open LLM leaderboard by Hugging Face, a log likelihood based evaluation. The same model was not highly ranked on the chatbot arena because the model has the core knowledge really good on the factual information, the factuality, okay? But it does not write its responses in a human aligned way. So people tend to prefer other answers than its own answer, even if the answer is factually correct. So that's like the battle between factuality and usability. And this is one of the ways that we try to tackle in the 3C3H metric, is to merge between the two. And that's actually why I discussed the two ways of doing evaluation so far. The knowledge, the automatic benchmarking, LLM leaderboard, for example, or the preference-based benchmarking, the chatbot arena, for example. So these are like two ways to do evaluation, and they are separate, and each of them has its own pros and cons. And 3C3H is meant, like so far, is meant to bridge between the two. It's more of an improvement on the LLM judge preference based, because it's mainly a preference based benchmarking rather than automatic. But it's meant to be more of an improvement on the chatbot arena style in general rather than the LLM leaderboard style. Because LLM leaderboard style, again, it's academic at its core. So it gives you an idea about the model performance. It gives you to an extent an overall idea. So during the training pipeline, it does not make sense to go to generative tasks when you are evaluating between the checkpoints. Okay, if you just want to see you are improving, automatic benchmarking using the MCQ benchmarks, all right, are way more than enough, because they give you a really strong signal about the model performance and the model evolvement across the iterations. All right, but once you have the model X ready to release, automatic benchmarking, MCQ benchmarks, does not necessarily mean it's a good model to release,
to be
even
used
if
يعني.
it's really good.
مم.
Because at the end of the day, you are interacting. This model will be used by people who are not necessarily technical,
مم.
or they just like have their own preferences. All right.
مم.
So you need to optimize for that, and the way to make this evaluation, the way to capture this is through generative tasks.
مم. جميل. طيب خلينا بقى نتجه شوية أو يعني إيه نروح للناحية اللغة العربية. هل شات بوت أرينا ما كانش فيها لغة عربية ولا فيها لغة عربية؟ تدعم اللغة العربية ولا لأ؟
I don't think so.
مم.
We tried to make a version of the
مم.
chatbot arena for Arabic.
مم.
We were not very successful in that
مم.
endeavor, unfortunately. Alhamdulillah, there is now a chatbot arena for Moroccan Darija by Atlasia.
مم.
It is ranking the models on
usability. مم.
Darija queries,
مم.
purely Darija queries. It's actually impressive. But
مم.
for the official chatbot arena, I remember there was Spanish, there was
مم.
Japanese, there was Korean, English, of course,
مم.
but I don't remember there was anything related to Arabic.
مم.
We try to reach out to the
مم.
authors, explore like paths of collaboration and like ways to do it for
مم.
Arabic as well.
مم.
But again, unfortunately, that was not a successful
مم.
endeavor.
مم. انا بسأل السؤال ده عشان عايز اعرف هل في يعني اختلاف ما بين ان انا ايفالويت لغة عربية وايفالويت مثلا لغة تانية في جزئية الجنريشن ولا لا. فهل في اختلاف
Mhm.
ولا هي نفس الفكرة؟
No, it's fairly the same.
مم.
It's fairly the same core idea. The way
مم.
you evaluate is constant, is
مم.
generally language agnostic.
مم.
Either using automatic metric, not blue score, log likelihood, rouge, whatever, or using LM as a judge in general, any way you want to use. The methodology of the evaluation is language agnostic.
مم.
So it's all depends on the benchmark or the questions. For example, in the case of the arena, there is no benchmark. You are the
مم.
benchmark.
يلا مش ممكن.
So
مم.
it's just like you would be given it the query in Arabic.
مم. مم. مم.
And I think I don't know this now when you give it like a query in Arabic, realized I have not tested it.
مم.
So yeah, I don't know what happens when you actually give it a query in Arabic.
مم.
The score like you know accumulate to the English one score on the rank the English one or what happens exactly. But yeah, I assume for the other languages they have a language identifier.
مم.
For example, for Spanish, Chinese, or Korean, the score would in that specific leaderboard rather than the English, leaderboard.
مم.
So yeah, but yeah, to answer your question, there is no difference in the way you evaluate way or from the questions in general. I would love to touch on some of the limitations of the chatbot
مم.
arena. Or that wave evaluation, not particularly chatbot arena, but any kind of evaluation. Elo score. So the Elo score. We continue.
Yeah.
Okay, we are back.
Yeah.
The For the Elo score for the chatbot arena in particular, but for any other framework that adopts the same methodology. The ELO score, for example. The ELO score is meant for evolving, it was created for evolving entities, okay? For example, in chess, you as a player, you are evolving with time.
Mm.
So your performance today is not your performance tomorrow.
Mm.
But Gemini 2
It's the same.
yesterday is the same as Gemini 2 today,
Mm.
is the same as Gemini 2 2 weeks later.
Mm.
Okay, so it's not an evolving model.
Mm.
That's one limitation. Second limitation is ELO score was designed for competitions with a clear objective: win, lose, tie. Okay, so for a chess, if you win a game, there is no two people on this whole planet will disagree that you won the game.
Mm.
Okay,
Mm.
you won the game. It's very clear, very deterministic. But for a model answer, you decide that model B wins because you like model B answer. I say model A wins because I like model A more than model B.
Mm.
That creates a problem. That's create the preference bias problem itself,
Mm.
and the question of how many people are using this platform to give their opinion about what model is better than the other. Is it like majority are Americans? And if the majority are
Mm.
Americans, are they like a proxy of the overall humanity
Mm.
preference? For example,
Mm.
if let's say O1 is the best on that leaderboard, does that really mean that O1 is the best for every human being on this planet? Anyway, that's
Mm.
like the injection of the human bias itself and how it's fairly not fair enough across like the whole population. And yeah, again, to, to come back to that point of like when tie lose, elo can be a really good one, effective metric for coding or for math, for
Mm.
example. Because if I ask you to generate for me a code, okay, you generate for me the code. You can just parse the code from the LLM response, try to run it on a virtual machine, all right? If it runs successfully, pass the tests, pass the unit test, that's a win,
Mm.
okay? If it does not, that's lose. Or if they both lose or they both win, it's a tie, okay? So that's a clear objective. There is no way to disagree on that. Well, at some
Mm.
point, maybe if they both win, maybe if they both codes pass the unit test, some people will say this is a more clean code than the other one,
Mm.
whatever. But in a more general basis, the two ones are for coding, for example, task. It makes sense to have ELO score on it because it's a competition.
Mm.
It comes, for example, from Code Forces, all right, or even for math. I mean, math is quite ambiguous because at the end of the day, do you want the whole proof of the theorem, or you
Or
just
just the
want
final
like
answer,
a
yeah.
specific answer?
Mm.
And the questions in math are not necessarily 5.03 as an answer, for
Mm.
example. Sometimes there's just like a formula, or there's just like, and for a formula, it can be like factorized, or it can be like developed in its form, and the same format could be written in different ways. So how to counter for that as well? Well, you can automate that in a way, but still, like, math is more of like in the middle. If you know how to do it exactly and you automate most part of the parsing and fact checking, you can adopt Illoscore in math as well. But for open-ended generation, for like multiple queries, general knowledge queries, it doesn't really make sense to adopt Illoscore for this specific reason in particular, because it's not a win-lose tie situation. It's more of like a preference bias,
Mm.
population bias
Mm.
situation, and that was captured in a way that people, because they were attacked, they absorbed the way ChatGPT generate answers. All right, they tend to prefer GPT models rather than Claude, even if the GPT model hallucinates more than Claude, for example. And this gives an advantage to ChatGPT, only because before consuming this technology, the first thing that they got exposed to is ChatGPT,
ChatGPT.
and they consumed it a lot. That they just like had it in their subconsciousness that that's the way to create a response, and any other way that is not similar to this, it's wrong, or it's less preferred. So that's like kind of like comments we have in general about Eroscore and Arena generally, and it was investigated by multiple research papers uh, as well, and for these reasons, we decided that that was one of the motivations to create 3C3H, as I mentioned before. It was really a way to correct. It was like an improvement over the preference based benchmarking methodologies in order to correct what is wrong with the arena style evaluation, the Likert scale evaluation from 1 to 10 give me a score for that response. In a more guided evaluation framework, so we are guiding the judgment or the evaluator on specifically 6 dimensions, and also to bridge the gap between the factuality and the usability of the model response that we discussed before. Factuality that comes from the automatic
MCQs.
benchmarks, the MCQs, and the usability that comes from the preference based. It was more like of bridging the gap between the two, measuring both dimensions at the same time, while making sure that we leave no room, or at least minimal room to any kind of bias injection or unfair, you can say, competition in general.
جميل. انا كنت عايز اتكلم على ال 3 اتش 3 سي. انا ما اعرفش انت يعني ممكن تقول قد ايه او تفاصيل قد ايه، بس يعني كنت حابب اعرف اكتر ايه كل حاجه بتعبر، يعني 3 سي دي بتعبر عن ايه و3 اتش بتعبر عن ايه، وازاي بتعملوا يعني ايفالويشن، وازاي بنيتوا الموضوع الموضوع. بس يعني ايه، انا ما اعرفش انت يعني تقدر تقول قد ايه في التفاصيل، فيعني ايه.
No, we are very transparent, and
اوكي. عشان
we
انت
are
قلت لي انت لسه ما عملتوش ريليز للداتا سيت نفسها، ف يعني ما اعرفش انت.
yes.
مم.
Yes. No, but in the methodology itself, we are very transparent, and in
اوكي.
March we will be
مم.
releasing the data set,
مم.
the model answers, the code,
مم.
and
ماشي.
everything. So yeah, just for people to have a
مم.
more like uh, overall idea. But yeah, for 3C3H, let's start with H, okay?
اوكي.
H stands for honest, helpful, harmless. And
مم.
we did not invent that, okay? We are adopting it from Entropic.
مم.
Entropic are mainly the people. I think there was some discussions before Entropic introduced that concept, but generally Entropic are the ones who popularized it in a way that these are the dimensions to optimize for and attack when you are aligning your model in the model alignment phase.
مم.
That's what we want our model to be. We want the model to be helpful to the user. We want the model to be honest, which means honest about its own capabilities and express doubts
مم.
and knowledge lack when it should. And we want the model to be harmless, which totally makes sense. All
مم.
right. Now for the 3C. The 3C, the first C stands for correctness. Is the
مم.
model answer correct? And that is the factuality.
مم. مم. مم.
Okay, that's
مم.
what we measure with the MCQs, for example, and
مم.
the log likelihood accuracy. That's we measure only the correctness. We don't measure anything else. Okay,
مم.
the other 5 dimensions, the 2C, the 2 remaining C's, and the 3 H's are for the usability,
مم.
to capture the human preference or the preference in general.
مم.
And here you can see is more complex to capture human preference than to capture the core knowledge. The core knowledge is very easy to capture,
مم.
binary, correct or not. But the human preference is more hard to capture. So going back to the 3C,
Mm.
The fourth C is correctness. Okay. The second C is complete. So the model answer should be complete. All
Mm.
right.
Mm.
And the third C is concise. And this is a very interesting dimension, because a lot of people, they say, well, a lot of model developers, they say, I don't want my model to be concise. Okay. Why?
Mm.
Because during the training, especially in RLHF, all right, the model, and again, Anthropic popularized the idea of helpful, honest, and harmless. So the reward models in general tend to measure these dimensions and give back the reward, all right, or
Mm.
the feedback to the model in order to optimize its answers, all right. So generally, there is a correlation between a more helpful answer is a longer one.
Mm.
So the longer your answer is,
The more helpful
the
it is.
more helpful
Mm.
your
Mm.
answer is. Okay, which is not necessarily the
Mm.
case,
Mm. Mm.
but this is one way of doing reward hacking.
Mm.
Okay, so the reward models being hacked just by giving a more verbose,
Mm.
more longer answer. And what we're trying to do here is it's more of like a call to the community that we need to pay attention to this. There is a sweet spot to balance between
Mm.
conciseness and helpful.
Helpfulness.
We
Mm.
want the model to be helpful,
But
correct,
not very long.
but also we don't want to, like, describe for me the same thing in 10 different adjectives.
Mm. Mm.
That's not helpful. That's
Mm.
wasting my time, especially
Mm.
for me. I use ChatGPT on a daily basis as everyone else, and
Mm.
after the whole response, I don't read it. I just like go to the
Mm.
last
Or
section.
go to
Okay,
just the
and
coding
that's not
part and take
helpful
the
to
codes.
me.
Yeah. Mm.
Yeah, and that's not really
Mm.
helpful to me, right?
Mm.
So what we're trying to do as well, as part of our evaluation effort, to like draw the community attention to this challenge, that the models tend to be less concise
Mm.
in order to hack their way to be more helpful in general. So yeah, that's like the kind of the definition of the 6 dimensions. And the way we are trying to
Mm.
measure this is using LM as a judge.
Mm.
So LM as a judge itself, you can consider it as a function. Okay, it's just a function. You can use a language model as a judge, you can use a reward model as a judge, you can use a human as a judge, you can use an oracle waiver, you can use a block box having waiver, like some complete complex math
Mm.
formula that you came up with that can map all and measure all these dimensions. It doesn't
Mm.
matter. What matters is it is a function that receives 3 inputs, 3 arguments. All right. The question, the
Mm.
reference answer or the golden answer of that question, and the model answer.
Mm.
And it gives back a vector of 6, a vector of dimension 6. Each
Mm.
unit of the vector is a
Yes.
score of that dimension.
Mm.
So the correctness is simply the core knowledge of the reference answer, all right, to
Mm.
answer the question exists in the model answer. Okay,
Mm.
so let's have it here.
Mm.
So we
Yeah,
we have like,
we can share a screen to the if you'd like. I can share the
yes, yes,
leaderboard. Yeah, I think it would
yeah.
be
Feel
helpful.
free, feel free to share the screen either for
Mm.
the blog post or the leaderboard itself,
Mm.
Arjun.
Yeah, let me share it here. Yeah, you can see it now, right?
Yes.
Yeah. Okay. Yeah. So here we have it.
All right. Perfect. So yeah, for correctness, it's simply if of the core knowledge that exists in the reference answer, and it answers like the question exists in the model answer.
Mm.
Okay, regardless of anything else, regardless of any other garbage or any other information or any other helpful thing, whatever. Regardless of that, we're just looking for the core answer.
mm.
That that is aligned with our reference answer.
Is the
The
reference answer is human generated, right? انتوا اللي عاملينها.
Yes, the benchmark is entirely human generated for
Okay.
both questions and answers.
Mm.
Yeah.
Okay.
And the completeness is okay. You correctly answered the question,
Mm.
but have you completely answered that?
Mm.
For example, if I ask you, I want to go to Egypt, and I am wondering how much is the tickets from Abu Dhabi to Cairo,
Mm.
and also, will it be raining on that day? I did not specifically say the day, but on next week, for example. And also, will it be raining on next week? Okay, but my core answer here is my core question here is how much is the ticket between Abu Dhabi and Cairo?
Mm.
So if you just provide me this information, that's correct. That's what I'm looking
It's not
for.
complete.
But it's not complete,
Mm.
right? Exactly. Or one of the questions is, for example, uh, which year was founded uh, the Arab League? Okay, مثلا.
Mm.
And what are the founding members and the members in general? Okay, if you give me, for example, which year the Arab League was founded and the founding members. Okay, الدول XYZ أسست جامعة الدول العربية سنة etc. Okay, that's correct. Okay,
Mm.
but if you don't attach with it the whole list of the members of the Arab League currently, that's not complete. I hope this
Mm.
draws some like this draws like some intuition.
Mm.
And what we can actually see is usually correctness and completeness are correlated, because
Mm.
obviously the examples I just gave are terrible. They are not correct examples.
Mm.
I'm just like I'll just thinking about them for now. But like usually a correct answer most likely is complete.
Complete.
For
Mm.
example, the first row for O1, you find that 92.71%, all
Mm.
right, of the answers we got are correct. And
Mm.
92.47% are complete.
Mm.
So
Almost. Yeah.
99%,
Mm.
yeah, 99% of the answers we got from O1, if they are correct, they are
Complete.
complete.
If they are wrong, it will be directly not complete, right?
No, if they are incorrect, it doesn't matter if it's complete,
Mm. Or
concise,
not. Mm.
helpful.
Mm.
It's already wrong. For
Mm.
example,
Mm.
and that's one of the limitations, for example, in the arena style,
Mm.
is the model answer could be wrong, but it's helpful, or it's
Mm.
honest, or it's harmless.
Mm. Mm.
Why would I care about that?
Mm.
It's fundamentally wrong. It's hallucinated, right?
Mm.
But people tend to choose it anyway because it's more aligned to them.
Mm.
That's what we're trying to draw here. That's the distinction we want to try to draw, is that correctness, the factuality, comes first as a measurement.
Mm.
Once the model answer is factual, then we see how usable
Mm.
or how useful it is to the user.
مم.
All right.
عشان كده
No.
يعني أعلى حاجة هنا 92.71 هي الهارم اللي هو هارمليسنس برضه نفس
Yeah.
الرقم يعني الاتنين تقريبا
Yes.
واحد عشان الحاجات
Yeah.
اللي مش
So
كوريكت أصلا
so
مش
so
هتخش على
yeah.
الباقي.
All exactly. So
مم.
all the answers that we got from O1, for example,
are
and
his
that were correct, they were also harmless.
اوكي
And
بس
you see between the top models, you see a 100%
سنت
correlation.
yeah
Yes, between correctness and harmlessness,
almost all of them
except
yeah
yeah, I mean
here
all of them, except for example that yes,
مم.
that one.
ده كوهير
That was Command R plus. So
مم.
Command R plus had some answers that were correct, but they had some harmful contents in them.
مم.
But usually what you expect is if a model answer is correct, it is helpful, honest, and harmless by
مم.
by
هنا هنا
by design. That's
حاجة
by
صغيرة
design.
قوي يعني، فرق صغير، وهنا برضو نفس
Yeah,
الكلام فرق صغير. اوكي.
correct.
ودايما هيكون
Exactly.
الماكسيمم اللي هو بتاع الكوركتنس، ان هو لو يعني ده الماكسيمم سكور في الباقي كله، ان هو ده طالما ده مش كوريكت مش هيخش اصلا في الباقي بقى، فهتبقى غلط يعني.
Uh, Not necessarily.
ليه؟
Uh,
يعني ممكن يبقى في حاجة اعلى من الكوريكتنس.
uh, n- well, because harmlessness is evaluated separately on correctness.
اه اوكي.
So,
but
for example, we try to regularize that
م-
later in order to have uh, a more like balanced score between all the dimensions. But for example, let's say uh, the model answers one question that was answered
م-
correctly, and it was given one, okay,
اوكي.
and that question was harmless, 5.
م-
You see why it's an issue. It's not like an issue by itself. It could be, but on a large scale it's less likely to happen
م-
because we have almost 300 questions. It's very less likely to happen,
م-
but due to the nature of the scores, correctness is either 0 or 1.
م-
Harmlessness is from 1 to 5.
اوكي. م-
Okay, so when you have this one regularized by 279, it gives you some number, but then you have to regularize the harmlessness from 0 to 1 in order to
م-
like convert it from the 1 to 5 scale to a 0 to
0 to
1
1.
scale.
م- م-
Then you need to average it again. So you
م-
might end up that it's not entirely reflecting the same correctness, for example,
م-
the same score of correctness. It
اوكي.
could be a difference, even though they are like for the same sample. It was only one sample that was
م-
correctly and harmful and
م-
harmless.
اوكي.
So, I mean, sharing the code later will give the people a more clear idea
م-
about how things works.
م-
Uh, as Linus says, show me the code.
to
So
me the
yeah,
good. Yeah, yeah.
once we show the code, that would make much more sense. But
م-
yeah, on a large scale, harmlessness shouldn't be more than
exceeding.
correctness.
Yeah, yeah, yeah.
Yeah.
م- هنا. هنا.
Now for conciseness.
م. دي اللي فيها
Conciseness,
ديفرنس
as you can
كبير.
see,
م-
yeah, conciseness,
م-
as you can see, it is much more challenging for models
م-
because they were
م.
not optimized for it.
يعني هو
Generally,
optimized للعكس actually صح؟
yeah, I mean, clearly you can see here that the
م-
best model in conciseness is O1. So
م-
that correlates with the like idea that the better the model, the more concise it should be.
م.
Okay,
yeah,
but this
yeah.
gives us way more room to grow.
م. yeah.
Uh,
يعني هو
so if you
بينزل فعلا
yeah, if you
يوصل.
rank by conciseness, O1 is the more concise the
م.
model. So
بس في
OpenAI
حاجة
4.
أظن أفضل منه صح ولا؟
Uh-huh, interesting.
سلمى. أوه نايس.
Ah, uh,
م.
that's a different story.
أوكي.
That's a different story. Okay, so Selma is the more concise one,
م.
but Selma, if once we will share the results, we saw some disturbing behavior of
م.
Selma. To be honest, you can see, for example, the completeness. It's
م.
twelve point
أوه
nine
يا
nine five.
حتى
So
الكروكنس قليل برضه.
most likely, Selma
أوكي، ما
is
بيطلعش
is
إجابات كاملة أصلا.
is
م.
responding in 2 or 3 tokens. It's
م.
more of like responding to an MCQ,
م.
as if it
أوكي.
was optimized to
م.
respond to an MCQ test. You
حتى
see,
عشان كده الهيلفولنس قليل.
is yeah, it's
م.
very low. It's not
م.
the responses we are getting from the model are not very helpful,
م. م.
and helpfulness and completeness are quite correlated as well.
م. م.
But to be honest with you, Silma was a really good during our studies that we will be publishing as part of the V2 of Origin. Silma was a really good example to draw the lines between these dimensions, because the better the model, for example, O1, it's very hard to draw the line between a complete and a helpful answer. But Selma was good. Selma was serving that purpose. Selma helped us clarify cases where the model answer could be helpful but not complete, or could be complete but not
but not
helpful.
helpful.
All right.
Mm.
So yeah, the Selma model was helpful in that regard as part of our ablation studies. But yeah,
نرجع نرتب تاني
to interpret
مم.
that conciseness score, it looks like, we don't know for sure, of course, as I told you before, there is no way to detect contamination, but it looks like that Selma, not necessarily on purpose, definitely not, but that's actually what happens most of the times, that by accident the model, especially for synthetically generated data, the model tend to the data that was trained on was like a couple of tokens as responses. So the model tend to
هو ده instruct، فممكن
make
هو
the
كان يعني
answer really short.
instructed، كان instructed fine tuned ان هو يطلع الإجابات بشكل يعني بشكل very concise يعني.
So that's one of the challenges of fine tuning. That's one of the challenges to keep in mind once you are aligning your model, or even, I mean, this behavior would less likely to happen if you are continuing pre-training. All right, because the objective loss is the next token prediction based on like token based, token after token, token after token. But for fine tuning, the loss function is a little bit different. So you are not for the overall like context, but you are optimizing for the response, because you have input, question, instruction, input. The question is the input, instruction, input, and answer, and you are only optimizing for the answer in an SFT format. So that's one of the that could be one of the reasons. I've seen comments from Selma folks that they are preparing for a second version of the model that is better with more data. They have more data, more expertise now, and I'm looking forward to it, to be honest. But yeah, Selma was good in that regard of drawing the lines between what could be complete and not helpful, or what could be complete and not honest, etc.
اظن احنا تقريبا غطينا كده اغلب الحاجات. انا كان عندي سؤال بس في الجادج بقى المستخدم، هل هو one LLM ولا بيبقى مجموعة من LLMs، ولا دي حاجة ما تقدرش تقولها؟
Great question. That's actually one of the things that we covered in the blog post, and we tried different things. We tried models individually, and we tried the jury strategy. Jury strategy is, instead of giving the judgment to one model, you ask a set of models to vote, and you take, for example, for the answer that we are getting from let's say O1, all right? We ask it like to be judged by Claude, by O1, by O3, by Qwen 72B, and by Llama 3.3. Okay,
It's not
5
يعني
models.
not fixed، كل موديل بيختلف ولا يعني الجوري بقى fixed؟
لا, الجوري fixed, but there are five different members of the jury, and each of the members do its own evaluation. And what we do is we go to extract the correctness. Okay. If three, for example, we have a jury of 5 members. If 3 members of the jury says the model is incorrect, the answer was incorrect, okay, then it is considered incorrect, even though the other 2 says it's correct. But the majority here says it is incorrect. So we do the majority voting. One other strategy we explored is the average voting. So if the model says for example, which is like it's serving to be like a more flexible way, because majority voting, it's democracy, and
مم.
democracy is not really like always the best regime.
ممكن ممكن تبقى الحاجة كوريكت بس
So yeah,
مثلا
so
ثلاثة يقولك إن
you
هي
are
غلط.
leaving,
مم.
yeah, you are leaving out the minority
مم.
uh, opinion,
مم.
right? So
مم.
what we explore as well is the average. So instead of
مم.
like taking the scores of the majority, we just like average the scores of the
مم.
whole jury. And what
مم.
we saw is this jury is not fundamentally different than using a single judge, and
مم.
both strategies, either voting, maximum voting, or average voting, it's not necessarily different. They end up to give the same results anyway.
مم. في
So
كله
there is no
في
fundamental.
ستة في ستة كرايتيريا ولا في الكوريكتنس بس؟
في ست كرايتيرياز.
ستة؟
For
أنا
example,
قلت
for
الكوريكتنس ممكن يبقى كده عشان هو يعني حاجة في الآخر يعني فاكت لكن
uh-huh.
الحاجات اللي هي سبجكتيف برضو بيبقى ليهم نفس الآراء فيها.
But that's the thing, because it doesn't matter how they will judge the other
مم.
metrics. If the correctness is zero, everything is zero.
مم.
But if the correctness is one, they are more likely, because they are already strong judges, they are more likely to be aligned in their
مم.
judgment.
judgment. مم. مم.
All right,
مم.
because at the end of the day, they are not judging by themselves. They are judging with respect to a reference answer, and
مم.
with respect to a detailed
اوكي
judgment prompt that is
مم.
detailing every dimension and
مم.
what each score of that dimension means,
مم.
right?
مم.
So they are more grounded, and that's what we mean by grounded judgment. We
مم.
don't leave too much room for the judge to be creative and to inject its own
مم.
biases.
act on itself yeah. مم.
We only use the language model as a judge because we want to capture the semantic differences.
مم.
When two answers, they are not the same, but they both answer correctly completely
مم.
the question, even
مم.
though they are
مم.
not the same. So
مم.
that's the
مم.
kind of things that you cannot automate,
مم. مم.
right? That's why, hence the usage of a language model. And as I told you before, it not necessarily needs to be a language model. It could be a
مم.
reward model, a preference model, an oracle, doing
مم.
whatever it wants, as
مم.
long as it gets 3 arguments as input and gives back a vector of 6 dimension.
مم. مم.
That's it. That's the only criteria. What happens inside, what's empowering the methodology itself, is not the core of the metric.
مم.
It's just like a proxy of a measurement tool.
Okay.
So yeah, that was for the judgment criterias, and why we decided to go with a more grounded way. And generally, we believe this is a better usage of LLM as a judge,
مم.
given the dispute in the literature over the usage of LLM as a judge. A lot of people are pessimistic about using LLM as a judge,
مم.
and we believe this is kind of like a solution to that, to the arguments of these pessimistic people.
اوكي نايس. انا عندي تو مور كويستشنز ممكن نختم بيهم ان شاء الله. الحاجه الاولى، هل انتوا عملتوا مثلا اناليسز للحاجات التوب موديلز بتغلط فيها بحيث ان تشوفوا اللاج الموجود ما بين الموديل واللغه العربيه مثلا موجود فين ولا؟
We haven't done that
مم.
specifically, but again, what we are planning to do is actually to release, and that's actually, I think that's a short design from our end. We should do that. We
مم.
should definitely do that. It's more of like a human power
مم.
question.
مم.
There is not a lot of Arabic speaking people in the field, and
مم.
most of the Arabic speaking people in the field are like me, with very terrible Arabic.
انا نسيت ان
So
انا اقول على النقطه دي، ان احنا يعني اللي باشمهندس علي بيتكلم انجليزي عشان هو اللغه المغربيه، اللغه العربيه بتاعته باللهجه المغربيه، فكان هيبقى صعب ان الناس كلها تفهمها، عشان كده هو بيتكلم بالانجليزي يعني. فانا اعتذر عن ده. انا نسيت، كنت المفروض اقول ده في
yeah,
الاول
we
بس.
apologize for that. اسمحوا لنا. But yeah, I think we should do that. We designed now for Origin 2, we designed it with using the same methodology that we used in Origin 1, the same philosophy, okay? Human generation for both questions and answers. But what we are hoping for is to get the feedback. Again,
Mm,
I emphasize a lot on this because it's really important, and we
mm,
are doing all of this like to be publicly available and open source for the sake of the overall community and
mm,
the overall field in the Arab region. So we are relying on the people to go check these answers, right, and gives us the feedback that's why some of the questions is not good and shouldn't be included. For example, what other questions that we could have included,
mm,
and for example, what anyway, and a general feedback about both the benchmark design and the metric design itself, as we will be sharing the uh, the system prompt of the judge we use in V2, in V1. In V2, we changed that system prompt to be more detailed, way more detailed, which we will be sharing again in June, and it's like kind of like periodic. I think the only shortcoming of this methodology is the feedback response is 6 months away. So, for
mm,
example, we release in March.
mm,
Okay, the feedback of the December version wouldn't be respond to until June. So
mm,
it's a kind of like a 6 month gap,
mm, mm,
because in June we'll release the March version,
mm,
and we will not be able to capture the feedback about the March version until September. All
mm,
right,
mm,
that's like I think one of the shortcomings. But again, we feel it's a necessity given the previous question that we discussed,
mm,
data contamination. We feel we it's an extra effort for us.
mm,
A lot of people actually discuss this dynamic evaluation pipeline before. It's not like a novel thing,
mm,
but no one like implemented it before, given its the high cost associated with it.
mm,
All right. So, but we feel like the high costs and the more effort that comes with this with such design is a necessity,
mm,
because unfortunately we saw some people that contaminate the benchmark,
mm,
rank high, and use the ranking in their marketing materials,
mm.
and and they even like they just like make the model public. They submit it in order to get high on their leaderboard,
And they
and
make
then
it
they make the model
offline.
private again, so just so they can take that screenshot and put it on their
Mm,
marketing
mm,
materials. It's really sad. It's really
mm,
sad. Such behavior cannot appear in English because the community is large, and if
mm,
someone do that, and there was an example that happened a couple of months ago of someone who contaminated the benchmarks and they end up to rank high, and then it was exposed,
mm,
and he went to like get a seed of $20 million, $50 million, something
mm.
like that, and everything collapsed on his head
Okay,
because
nice.
the community exposed him
Mm,
very fast.
mm,
That's the thing they rarely happen in English because the community is too large, and if
mm.
you do it, you will most likely get caught.
Exposed.
But in
Mm,
Arabic, Hindi, Kazakh, Japanese, it's more like in the resource, and even if someone speaks about it, there is not a lot of people who are gonna hear
mm,
about it.
mm, mm,
So people tend to say, okay, whatever. Like most likely, I'm not gonna get caught.
mm,
So for these reasons, we decided that to maintain the truthfulness of the benchmark.
mm,
And once we release it, we replace it entirely with a new benchmark, and we
mm.
only release it in order to
Get
make
feedback.
yeah get the feedback. And also, well, at the end of the day, we are model developers as well. So why you trust us? Why you trust us with these rankings? All right.
Mm,
Uh, so this is like for more like
mm,
establishing trust with the community that, look, we are very transparent, and the results we are reporting here, you can reproduce them again.
mm,
So there is no play in, there is no game under the hood whatsoever.
mm. اوكي. انا عندي سؤال اختم بيه، بس قبل ما اختم سريعا، هل عشان اقفل الداشبورد، هل كان في اي حاجه يعني سربرايزنج للمودلز اللي جت رانكد، ولا كله يعني، ولا كان متوقع، او في اي مثلا نوتس عندك على الرانكينج بتاع المودلز؟
Uh, Not really. Like one of the surprising things is 3.5 HiQ is better
امم.
than O1 Mini, given both of them are small models. Well,
اوكي.
small
امم.
models,
امم.
relatively small
yeah.
models. Okay. The gap is not too huge,
امم.
but that was one of the comments
امم.
that we discussed, because O1 is supposed to be a reasonable models,
امم.
and it is directly distilled from O1 itself,
امم.
most likely. So yeah, this is like the only thing that we thought it could be the other way. We thought that it
امم.
could be like O3 Mini, then O1 Mini, then Claude 3.5 HiQ,
امم.
but it happened like the other way. Uh, yeah, but generally you can see here that the models ranking uh, are correlated with the size
امم.
and the capabilities in general. So everyone is mentioning that O1 is really really good, and we can only like expect the same on other language.
امم.
That actually is the case. So there is no surprise here, and that's actually the good thing about generative tasks is the evaluation methodology is explainable.
امم.
Whenever you have some doubts, you can just fact check the
امم.
answers, okay? And you are good. It's very explainable. You can make sense out of the evaluation.
امم.
In MCQ evaluation, especially within the log likelihood accuracy, it's less explainable, and I would say less reproducible as well to an extent, but mainly less explainable. You can check the wall 2 we released recently. Okay, and I'm working on both of them. Yes, but I'm not gonna say wall 2 don't have its own limitations. It clearly has its own limitations, but the limitations are not for the in wall 2 specifically or in the benchmarks, but the evaluation methodology itself, log likelihood. Because let's give you a very simple example, and I hope that sticks with the people who are listening now, to think about it. Again, we are taking 4 tokens A, B, C, D, and we are measuring the highest probability in those models. One of the cases that we found in JAST, for example, that if the correct answer is A, okay, we look at A, B, C, D, all right, and we find that B for JACE, for example, 30B, or even JACE 13B, B was higher probable than A. Therefore, the answer is incorrect, okay, by the metric design. But if you take a look in all the tokens, you find A with a parenthesis has a higher probability then A, then B. So if you consider all the combinations of the first
اوكي.
token, all right, you find, for example, A with a parenthesis more probable, then B, then A,
اه.
then for
اوكي.
example B with a parenthesis. This is
امم.
one of the limitations of the metric.
امم.
Okay, so we are penalizing a model that actually knows the correct answer. It's
امم.
just not giving it in a single token A, but in a single token A with a
ايه with
parenthesis. This
with
is
a
one of the
yeah.
tokens as well.
امم.
So yeah, this is in one way this is related to instruction following
امم.
evaluation, which is
امم.
one of the axes we are working on at Inception as well, of evaluation, and we hope to release it very soon, inshallah.
ان شاء الله.
That JACE as well is not highly optimized for instruction following,
امم.
which negatively impacted its performance on other tasks.
امم.
And that's why like we believe that generative tasks is more, more reflects better the actual performance of a model, and that's the direction we are driving so far.
جميل. خلينا نقفل الشير ونختم بسؤال أخير، وهو ايه يعني المشاريع اللي انتوا شايفينها محتاجينها لسه في الايفالويشن للغة العربية، بحيث إن لو حد حابب يشتغل على مشاريع شخصية، مشاريع تخرج، او آه يعني ايه الجابس الموجودة، وايه لو يعني خلينا نفترض لو انت مثلا عندك unlimited resources، ايه الحاجات اللي انت شايف ان يعني ايه هتبتدي تحط فيها الريسورسز دي، سواء human او budget resources يعني.
Interesting. Well, money wise, resources can help a lot,
مم.
but the most important resource is human resources, which we suffer from,
مم.
unfortunately.
مم.
Yeah. So currently, for example, in Inception, we are laser focused on evaluation. Honestly, I've never seen a company in the world that is crazy focused on evaluation like we are now on multiple axes. And one of the things we are doing is this Origin, and now Origin V2 gonna come in the next month, and there will be follow up similar evaluations for other languages as well to support the Global South mission in
مم.
general. But also we are focusing, for example, instruction following evaluation. We're focused on, like, for example, multimodal evaluation for Arabic,
مم.
and
مم.
recently we've seen many models
مم.
that are multimodal for Arabic, and we believe that we will release a leaderboard for multimodal Arabic soon,
مم. ان
inshallah.
شاء الله.
But at the end of the day, we are very restricted by the human resources we have, and each one of us has 24 hours.
مم.
So we believe that there is the community can really help in other kind of evals and leaderboards. One of the bottlenecks is the cost associated with evaluation.
مم.
It's not cheap, even
مم.
though people tend to frame it as the
مم.
cheapest
Because it's cheaper
component.
than training, but still expensive.
Yeah, it is
مم.
cheaper than training, but generally it is not cheap. It is
مم.
really
مم.
not cheap
مم.
to empower leaderboards. And for that we are willing to support like any individual or a community or a lab that is willing to create a
مم.
certain leaderboard. One of the axes that unfortunately we're not currently following, we would like to follow given more human resources, and we would like someone else to follow and give feedback on it, is reasoning, for example.
مم.
What is reasoning for Arabic?
مم.
So far, reasoning is not clearly defined.
مم.
Most likely it is associated with math. So you have a
مم.
math data set, then it's reasoning. And that's how we did it in Origin, to be honest, as well. We have a reasoning task, and mainly there was math questions, okay, and some riddles.
مم.
But yeah, reasoning. What is reasoning for Arabic, and how to create benchmarks
مم.
in Arabic reasoning. And because what's true for English doesn't necessarily mean it's true for Arabic. Maybe we
مم.
have reasoning tasks in Arabic that eh, simply English don't have, right?
مم.
Uh, besides reasoning, there is also the question of safety. Ara Trust was a step forward in that regard. But as you can check the wall ranking, and you will see that it's kind of like saturated already.
مم.
It's couple of days that was released and it was saturated already. Not because people are training on it. The questions were human generated by SAS people,
مم.
but I believe it's more of like design challenge. We would love to see Aratrust 2 a more challenging safety dataset for Arabic. You know, that models tend to perform less on it
مم.
in order, because this is the only way we
To
can,
improve the models, yeah.
yes, improve the models and see where the models tends
مم.
to do worse.
مم.
Because the overall goal of evaluation is not to prove that a model is good,
مم.
but the other way, to prove that a model is
مم.
bad.
Yeah.
That's what we're looking for. We are looking for these sweet spots where the model fails actually.
مم. مم.
And that's the goal of evaluation.
مم.
We are the nemesis of model developers.
مم. جميل جدا. انا اتبسطت جدا، يعني الحلقه دسمه وانا استفدت منها كتير قوي على يعني من المحتوى، وان شاء الله الناس تلاقيها مفيده. اظن يعني مفيش
يخليك.
ناس كتير بتتكلم في جزئيه الايفالويشن دي. ف...
صح.
فباذن الله الموضوع هيكون مفيد، وفي انتظار بقى الاصدارات من انسبشن، الارب جين فيرجن 2، وانتظار برضو الريليز بتاع الداتا والكودز بتاعت الفيرجن 1.
ان شاء الله.
كله توفيق ان شاء الله، يعني بتعملوا شغل عظيم،
ربي
وان
يخليك،
شاء
ربي
الله
يخليك، شكرا.
تستفيدوا انت اكتر
شكرا
واكتر يعني.
جزيلا سيد يوسف على على الاستضافة.
ربنا يكرمك يا علي. انا فعلا استفدت جدا، والحلقه مفيده يعني. شكرا على على المعلومات والكل الحاجات اللي انت شاركتها معانا يعني. ونتمنى الناس تكون مفيده، الناس تلاقيها مفيده. والسلام عليكم ورحمه الله.
ربي يخليك، شكرا، مع السلامة.